Hello, Keller class. We're going to be doing some science this afternoon. It's Monday, the 18th of January. And the last 2 weeks, you've been looking at and thinking about solids, liquids, and gases. Just have a little moment and think about what kind of things you can think of that are solid. I asked you to make a list last week, which lots of you did do. So what sort of things are solid? And what about liquids? What does a liquid have to do? What property has a liquid got? And gases, can you see them? Can you smell them? Can you touch them? Okay, so this week we're going to be going on and moving on to looking at heating and cooling. So you'll need a pen and a paper, and you can pause this video and stop and have a think, or you can rewind it, or you can watch it again. Okay, so let's move on. Let me just see if I can find my little screen share. Okay, oops, there we go. So today we're going to be investigating materials as they change state. So that changing state is understanding how heat can cause solids to change to liquids and liquids to turn to solids. You're going to be identifying materials that melt at different temperatures, and we're going to be investigating the melting and freezing temperature of a material. So what makes materials change state? Materials can be in 3 different states. They can be solid, like those ice cubes. They can be liquid, like the water, or they can be gas. But how do materials change state? Have a look at this diagram and choose the correct labels for each arrow. So which one is freezing and which one is melting? That's right, that one is freezing. So when liquid moves to solid or changes to solid, it means it's freezing. So that means when the ice cubes, the solid, changes state to liquid, that's called melting. And lots of you were telling me about going out in the snow last week. And I'm sure when you picked up a snowball in your hands, it started to change state very quickly, going from solid to liquid. So what makes materials change state? Okay, when a solid turns into a liquid, it's called melting. The temperature at which a solid material melts is called its melting point. Different materials have different melting points. If a solid material is heated to its melting point, it'll start to melt and it will change state from a solid to a liquid. So have a little think about things that you can think of that melt. So we've talked about ice. Ice melts. What else can you think of that melts? In a solid, the particles are closely packed together and are vibrating on the spot. When a solid is heated, the particles start to move faster and faster. If enough heat is applied, the particles will have enough energy to move about. They're still close together, but can move over and around each other. So at that point, the solid has melted to form a liquid. So you can have a look there at the particles. So the ones at the top here, they're all quite far apart and moving around, and then they change so they're all tightly together and they can't move. So this shows a liquid changing state to being solid. And here would be a solid like the ice cube changing state so the particles move around and vibrate together. Melting and freezing points. Can you see this thermometer here? Look at the numbers. So it starts at 0 here, and then goes up to 5, 10, 15, 20, 25, 30, 35, 40 degrees Celsius. And then below 0, it goes to -5, -10, -15, -20, -25, -30, -35, and -40. That would be very, very cold. Okay, for most materials, their melting and freezing points are the same. Although it sounds strange, think of the melting and freezing point as a barrier, like a wall. If the material is heated to a temperature higher than the wall, it will melt. If it's cooled to lower temperature, it will freeze. So 0 degrees is the freezing point of water. So if you get a glass of water and you cool it to 0 and below, it will start to freeze. It will start to turn solid. If you get some ice and heat it above 0 degrees and higher, it will melt and become a liquid. Maybe you could try that at home. Okay, get an ice cube and see what happens when it melts. Can you match these materials with their approximate freezing and melting points? So we've got wax, butter, gold, aluminium, silver, and ice cream. Let's have a look. How did you do? Well, we don't know yet. We need the answers, don't we? Why would it be useful for somebody to know the freezing and melting points of these materials? Who might need to know the freezing and melting points? Okay, so wax melts at 50 degrees Celsius, so that would be like a candle. Butter melts at 35 degrees Celsius. So if you held butter in your hand, it would start to melt. Gold is a very, very strong metal, so that needs to be heated at 1060 degrees Celsius. That's an awfully high heat, that one, isn't it? You'd need a very special piece of machinery to melt gold. Aluminium is a type of metal, and that melts at 660 degrees Celsius. Ice cream melts at 0. Again, if you held ice cream in your hand, it would melt, wouldn't it? On a very hot day, if you've got an ice cream, it melts very quickly because the temperature is usually above 0 degrees on a summer's day. And silver melts at 960 degrees Celsius. Silver is a type of metal as well. So this is Maya. She's getting the food ready for her birthday party and wants to make some chocolate crispy cakes. Her party is only a few hours away, so she needs to make them fast. She needs to know the best temperature for melting chocolate. When she has melted the chocolate, she can add the cereal, shape the mixture into cakes, and leave them to freeze in time for her party. Can you help her find the best temperature for melting chocolate? Okay. This is what you can do at home now. So you'll need to freeze the screen. You'll need to place a piece of chocolate in a foil tin and float each tin on a different temperature of water. So you could have cold water from the tap, hot water from the tap, and hot water from the kettle. Please make sure you've got a grown-up with you to help you do this. You will see how long it takes for the pieces of chocolate to melt at different temperatures. So if you haven't got chocolate, you can do this with an ice cube. So put an ice cube in a little bit of in a tin, or a little bit of foil. Make a little cup out of tin foil, and put the ice cube in on top of cold water, on top of hot tap water, and on top of boiling kettle water, and see how long it takes for the ice cube or the chocolate to melt at those different temperatures. When you've done that, I'd like you to take a photograph of your work, and I'd like you to write about it and send it on Dojo, please. Okay, so that's your work today, everybody. I'm looking forward to seeing your work later on. Okay.